Okay guys, so we're going to be graphing polynomial functions here. These first couple that we're going to play around with are already in factored form. So it's going to be easier to find the zeros, but it's a little bit harder to find the end behavior. Okay, we need to find out what the degree of the function is and what the leading coefficient is. All right, so if I were to multiply or distribute these three binomials, I would end up with a leading term of x cubed. Okay, x times x times x would be 1x cubed. That makes this a third degree polynomial function with a positive leading coefficient. All right, so what that means is the end behavior is going to be as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. Okay? Next step is to find the zeros. That's the x-intercepts or the solutions of this polynomial function. All right, so we've already in factored form. We're going to set each of those factors equal to 0 so we can find the x-intercepts. Okay, the first x-intercept is going to be -2. All right, that factor only occurs one time. That x plus 2 is to the first power. That means we have a multiplicity of 1. All right, that's important because it tells us at that point the graph is going to cross the x-axis. If we have an odd multiplicity, the graph will cross the x-axis. If we have an even multiplicity, we'll talk about what happens in the next problem. Okay, second x-intercept is going to be x equals 1. Again, that factor only occurs one time, so we've got a multiplicity of 1, so the graph will cross the x-axis there. Third factor gives us a 0 of x equals 3. Odd multiplicity again, graph will cross the axis there. All right. Next thing we want to find is the y-intercept. Okay, it's a little bit harder here. It's actually easier in standard form to find the y-intercept. So we got to do a little work here. We're going to plug in 0 for all three of the x's. We're going to do a little math, and that gives us a value of 6. Okay, so the graph will cross the y-axis at a value of 6. Okay, now we've got 4 key points there. All right, 4 critical points that we're going to be using to graph the function. Now we want to test some other values on each side of these intercepts just to give us a clearer picture of what the graph looks like. Our graphs don't need to be exact here. Okay, we just want to do the best we can to put these graphs together. So our smallest x-intercept was -2. I'm going to go just to the left of that and plug in -3. Okay, when I plug in -3 to the original function, I get a -24. Okay, so the point on the graph there will be -3, -24. It's not totally necessary to find this value because we already know what the end behavior is going to look like, but we just want to see how fast that y value is growing, or in this case, how fast that y value is getting smaller. Okay, we already know at -2 we've got an x-intercept, so we know another point on the graph. I want to go a little bit to the right of that now and plug in -1. Okay, plug that in, do the work, and you get +8. So I know the point -1, 8 will also be on the graph. Okay, next value over is the y-intercept I've already calculated. Okay, so we know 0, 6 is going to be there. All right, let's plug in +1. We know that's an x-intercept or a 0 of the function, so I know 1 0 is on the graph. Okay, let's plug in +2. All right, because that's in between our intercepts of 1 and 3. Okay, so I'm going to do all the work and I get -4. Okay, so that tells me 2, -4 is going to be on the graph. Next, I know 3 is an intercept, so I know that point has to be on the graph. And finally, I just want to plug in 4 just a little bit to the right of that last x-intercept just to see how fast this function's growing, and I get a +18. Again, the first value we found, -3, -24, and this last value or point we found, 418, not totally necessary because we know the end behavior. So if you want to cut those two out to save yourselves a little bit of time, fantastic. Okay, so let's look at the graph of that function, and then we'll move on to number 12. All right, so the graph for number 11, we've got the 3 x-intercepts at -2, +1, and +3. We've got the 1 y-intercept up here at 2, 4, 6. Okay, we know the end behavior from this intercept over here is going to go like that, and we know the end behavior over here is going to go up like that. Okay, So remember, the 2 points that we found to the left of our smallest x-intercept and the points to the right of our largest x-intercept, those were just for kind of our understanding, but for general purposes we don't need to plot those. So we're going to plot the -1, 8, which is going to be up here, okay, and the 2, -4, which is going to be down here, okay. So using the test points that we found and all the intercepts, we know the graph is going to look like this, okay. Remember, all of our multiplicities were 1. So at each of those x-intercepts, the graph is going to cross the x-axis. All right, so there's the graph for number 11. Number 12 here, we've got the function p of x equals x plus 2 to the 3rd power. Notice that factor is occurring 3 times there. X plus 2 as a factor occurs 3 times. The next factor, x minus 1, occurs twice. Okay, that's going to be important. End behavior. Okay, end behavior. We're going to have, if we were to expand both of these binomials and kind of multiply everything all the way out, the first binomial would have a first term of x cubed. The second binomial, when we square that, that would be x squared. And then when I put them together, our first term in this function, if we were to multiply everything out, would be 1x to the 5th. Okay, so that makes it a 5th degree polynomial with a leading coefficient of 1. Okay, so just like the last one, we know what the end behavior is. As x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, so does y. Okay, now I've only got 2 factors to play around with here, so we're only going to have 2 x-intercepts. Okay, the first one is going to be -2. Okay, that is a multiplicity of 3 because that factor occurs 3 times. Again, that's an odd number of factors, so that 0 occurs 3 times. So we're still going to cross the x-axis at that value. Okay, the next 0 is going to be +1, but that factor occurred twice. Okay, so at that point, we've got a multiplicity of 2, an even multiplicity. So this is the first time you've seen this. The graph's actually going to bounce off the x-axis there. Okay, so it's not going to cross the x-axis. It's going to go exactly to the x-axis at 1, 0. Okay, and then it's going to bounce back whichever way it was coming from. All right, y-intercept, again, we want to plug in 0 here for x. Do the math. We get 2 cubed times -1 squared, which is +8. Okay, so our y-intercept is at 8. Okay, so we only got 3 points here, 3 intercepts that we're working with. So we're going to have a little bit, we're going to have fewer values in our table here. We want to go a little bit to the left of our smallest x-intercept, -2. We're going to plug in -3. We're going to do all the work, and we get -16. Okay, again, I'm going to let you cut that out if you want to, because we already know the end behavior, and we're just really drawing a quick graph here. Next point we know is our x-intercept, okay, and the graph will cross the axis there. Next value, -1, we actually got to do a little work here. We get +4 when we plug that into the function, so the point -1, 4 will be on the graph. Okay, next value we know to be our y-intercept, so 0, 8. Next value is going to be our second x-intercept. We know the graph is going to bounce off the axis there because there's an even multiplicity. Okay, so 1, 0. And then finally here we want to go just a little bit to the right, plug in 2, and we're going to get a fairly large value here. We're going to get 64. Okay, again, we're not going to plot 64 on a graph. We're not going to have a grid big enough for that. We're not going to change the scale. So let's plot those points and see what the graph looks like. All right, so the graph of number 12. Remember, we had 2 x-intercepts here at -2 and +1. We had 1 y-intercept up here at +8. Okay, remember the end behavior again from these intercepts. This is going to go down here like this again, and this is going to go up here like this. Okay, so now we're just looking at what's happening between those intercepts. Okay, so we plotted one other point that we're going to use. The 2 points, -3, -16, and 2, 64. Those are just to kind of verify our end behavior was correct. You don't have to find those, I've said. We're just doing a general graph here. Okay, So at -1, +4, we've got a point, so we know our graph's going to go through there, okay? Remember, the multiplicity of this x-intercept was an odd number. It was 3 in this case, so we're going to cross the x-axis there. We have to get to that test point we just found. We're going to get to the y-intercept, and then we're going to turn back down to here, to that x-intercept at +1. Remember, this x-intercept occurred twice. That factor had a multiplicity of 2, so that's why we talked about the graph was going to bounce off the x-axis, not cross it, and then turn back up, okay? And that's verified by this point, 264, okay? So this is a very general graph for the function p of x equals x plus 2 cubed times x minus 1 squared.